Hello, everybody. So I've got a few things on the list to talk about tonight. A couple things that showed up in this week's project, kind of like we saw last week with just to mention what they mean. You've probably seen them a little bit before. A couple things to talk about with the project, and then kind of continue where we were last week, looking at movement, in particular movement of the opponent characters, getting some stuff going for that, while our weekly assignments are about something else. Does anybody have any questions before I start talking about some points from that showed up in the assignment, making sure what's going on there is clear? Sort of like we did last week, the generalization, so that you see this in all of your other, you know what to do in other languages. Okay, I assume the silence means no questions. So one of the things that was in this week's book is we were using that XML data for images. I'm talking about image stuff here in a moment, which is a text file. So we had that word showed up. I think the whole thing for C# syntax is right before we talk about something, we say system.serialize in square brackets, and then do our class. Public class. I'll just write some abbreviation, and then do all the class stuff. And what this does is serialize allows us to write the stuff to a file. There's some internal workings. It basically says this is something that can be written to a file. We have to explicitly define what type of data can be written and cannot be written to a file. It can be security risk if we write the wrong type of data to a file. So we have to be careful with it, and just to avoid, I guess I said it for the error on the side of caution. So instead of explicitly denying the things we don't want to be able to write to a file, we went the other way and just explicitly state the things we do want to be able to write a file. So if we don't include that line, we can't write a file with it. With our object, right? Some things like a string to a text file, which is one of the things I put on the to-do list today, because I think at least some basic save functionality will be useful for some of y'all's projects. A string is an object that we're often going to write to text files, so that's already serializable, and a lot of the built-in objects are serializable. It'll make sense which ones are, but whenever we define our custom objects, if we're going to write it to a file or read the data in from a file, we have to say it's serializable. We might need the able. We need to serialize our data. So in C# we say it's serializable. And to tie that into other languages, C++ doesn't have any such restriction. We can do whatever we want in C++, so we don't have to worry about it there. If we have data we want to put in a file, we just bit shift. The easiest way is if you don't have anything else, just bit shift over into a file. The two angle brackets to take whatever bits or bytes and kilobytes and megabytes, however much data you're looking at, and just move those bits to a different place on the system. That can be a bit of a problem. So most of our languages that were developed afterwards, most of the programming languages we work with, have precautions to avoid the accidents that can happen when we do that with C++. Java, we have to put that right in our class. So again, after we finish this, if you decide you don't care much for Unity and want to switch over to JMonkey, and that way you can, because you like working in Java or something, we have to implement a particular interface say public class again, give it some sort of name. And then we need to implement serialize. I think it is serialize in Java. It might be serializable. I should have looked it right before class, but there's a particular interface we have to implement, which if you open it up and look for it, looks really odd because the interface is I know a lot of people, first time they see it, think it might be an error, but it's a public interface serialize. There's an opening curly brace and then a closing curly brace. That's the whole thing. There's no code in there. But internally, the file writing string, all the stuff on scanners in Java to write, just have a condition to check and make sure that that interface is there. And a lot of people, first time they see it in Java, think that's an error. But we have to do that same thing. We have to say that that's something we can write to a file. This in Python would be the other big one to look at. You want to use the pickle module, which is a verb that we no longer use. In the late 80s, when Python was created, there was a lot of different vocabulary and terminology going around. Different people would call things by different names. And eventually the IT field in general settled on serialize, whereas Python, when they created Python, they used another verb to pickle our data, kind of like the food preparation thing. We have to make some modifications to the data so that it fits in the long-term format and stored, so it can be stored and retrieved without getting messed up. It relates to the food terminology of preserving stuff. We pickle things. I guess in America, the only thing we ever really pickle is cucumbers. But we can do that process of using salt and vinegar to make sure the food lasts basically forever on all sorts of stuff. Just doesn't taste as good when we do it on things other than cucumbers. But Python still sticks with that other verb, so we have to use that to make our custom data able to write to a file, or just turn everything into a string. That works too. I guess there's some other, depending on how you're going to do the thing. Python also has improved modules to write to XML, like our project this week did. Prototype, that's the word. Like our prototype this week did, or JSON, or whatever format you choose to store your data in. Or again, you always just turn it into a string and put it in a text file. That works too. That's what I was going to go over tonight for some basic file writing things. So that's a common thing. When we're going to store stuff or retrieve stuff from data from long-term storage, we do have to explicitly serialize our data. As far as that protection thing of, in C++, we're not restricted. We can put whatever bits we want, just move them right over to the hard drive. But that can cause problems if we move the wrong bits to the hard drive, or things can get messed up there. So a layer of protection and security and stuff. So instead of explicitly stating what we don't want to put there, we just make the assumption that we don't want to put anything there and explicitly state the stuff we do, that we do want to be able to store. Is where serialize comes from. Or pickle, if you like working in Python, which is an old verb that means the same thing. There was a lot of competing terms at that time, and Python's the only one that still really uses that verb anymore. Most people probably don't even really remember what it meant unless they were using computers back then. What else do I have here? Oh, something implied. Oh, also talk about enums. Has everybody seen enums before? Short for enumerators. The project that or prototype this week does include an enum, and basically it's just a short list of things. I'll share my screen and just do a quick example of a couple of enums. I'll save this so I get some color change for to see stuff. That didn't work. Let me try that again. Save as enums.cs. That way I get the color change. That was the whole point of doing that. Oh, so not like emu, short for enumerator or enumeration. But basically, I mean, it's when we have a short list of options. So the suits from this week's thing would work. We'd set up we're used to making out class objects, so we'd set up a whole bunch of things, but really it's more like a single data type, which kind of is what a class is, but instead of one really long option, right? We just said enums integer, we can fit any number of integers in there. In the case of the suits and a deck of cards, we only have a couple options. It'd either be hearts, clubs, spades, or diamonds, and no semicolon in that one in C#, which might seem a little odd, but it gives us just a short list of options we could have. And then when we have our actual class, public class main, yeah, public static void main. Whenever we have our public class, then we can call an instance of that, the thing we're actually using, which I should do like the ones we've seen. The Unity engine itself has our public static void main loop, so we don't ever have to write that. All our stuff is monotype behavior, mono behavior. Always typed in there. I'll try to put some extra words in there. All our stuff is always mono behavior, or a child of mono behavior, and then we can just start putting things in like a public data type, like that one we just made. And our card has to be one of those four things. So it just gives us a short list of options. Is suit.cards. And I've always treated them like constants, where, well, really just for the way it gets typed. And type them in all capital letters because it's kind of like constants. We only have 4 possible values to put there. Or tax brackets might be another extreme of the examples. And depending on what our salary is, we're going to be in a drastically different tax bracket. Or middle class, rich, and there's different options. So like public tax bracket, which y'all might remember from filing your taxes, there's not a, whenever you get your adjusted gross income and all that, you don't have a number particular to that. You take that to a table and find which range you're in. So there's a short list of things that we could be in to figure out which tax bracket we're in. I don't know, maybe somebody named Bob has a tax bracket of middle class. And then later we could check that, right? If Bob is equal to text bracket dot middle, then we know what his rate is, right? Float rate is, I don't know, I guess 23%. Sounds about reasonable for a thing. So we can check, we can do checks on them afterwards. And it is an enumerated value. So they do count as numbers, the order we put them in. You get a 0, 1, 2, if you need to check it that way. In C#, we could also do other things. Like we'd say 4 is 15, and then middle would be 16, and rich would be 17 in this case. So it enumerates things, it assigns them to an integer, but more meaningful words. Our code can look a little bit better. If you've seen those before. In Java, we can do more. In other classes, Java and C++, we can kind of extend that. It's a special type of structure in C++, if anybody's worked with that. And in Java, this part would look the same, but then we can add some methods right into it. For C#, we have to do a public class called extend, which is a special type of keyword. And then we can add some methods in that. It's a whole lot easier just to do a check in your code, but it gives us a short list of things to work with whenever there's only a couple of options, right? Public enum color. Our color is either going to be red, green, or blue. Just a list of 3, or new fan. Fans are either going to run at low, mid, or high. And then we can do different things based off which one it is on the short list. And it gives us nice words to put in our code to help it make more meaningful, instead of just saying, okay, this equals, oh, wait, that's a typo. That should say like hearts. Hearts, yeah. So that suit enumerator, and one of the values in there is hearts, which essentially is saying that card value is an integer holding the number 0, because that was the first one we put in there. But we get much more meaning, we get something much more meaningful when we look at our code that way. And I'll keep track of it. Should look very similar. In Java, we're actually allowed to put methods right in there. With C#, we have to do that a special type of class called extends. Like give it the name extends, and then put our methods there, and it will try to apply those methods to a enumerator object. But it's a lot easier just to check it yourself. It gives us nice, meaningful, enumeration means numbers. So it's a quick way to get meaningful words to a list of numbers. Is one way to think about enums. A useful thing, the main thing is, I always just refer to it as, it's just the short list. When we have a short list of options that things could be, it often works best to put it in that way. Okay, I had a note in here, looking through the book, and I didn't think they made it quite very clear when they talk about it in the book. And usually when things like XML are introduced, or markup languages in general, most people get the introduction to that in HTML anymore. There was a time where we had to use those a lot. Like when I was first learning computer stuff, was in that span of time when printers could do way more than screens. The printers were way better. Even cheap printers were way better than expensive monitors. So if we wanted stuff to print on the page, we didn't have a good way to show it on the monitor. So we use markup languages to introduce it there. But whenever we have things in markup languages, so like XML, all the stuff that goes in the tag there. I don't know, make up some player data. So we have player data, and we might have things like a hit points tag with 34 in there. And the hit points, magic points, 16 in our magic points stuff, and all the characteristics about our player, the stamina. We put those into tags to organize them. In the stamina. And it's a text-based way of storing our data in the player attribute. So it's usually not introduced very clearly when we're learning HTML. Has everybody seen markup languages before? At least your HTML class? Okay, I see some yeses there. So the biggest thing about this, every piece of data, I'll point at hit points here. Every one of our data points says where it starts, where it stops, and I saw a bunch of yeses in the chat room about having seen markup languages before. So we also have the attributes. So there's also metadata. So we have the start point, the stop point, metadata, and the attributes, and the data itself. So it's almost the ideal form to go through a CPU. It's pretty much the perfect thing for a CPU. Every single piece of data, we don't have to worry about sizes or anything. Everything includes its start and stop point, the data itself, metadata about it. So it's really good for a CPU. It's along with being in human readable form. So we get that combination that it's not bad for a human. It's great for a CPU. So it's a very common thing. And it's often not introduced very clearly that this is object-oriented. It's not the class like we're used to seeing, but we've been using angle brackets a lot when we do our stuff in C#, right? Every time we need to grab something, we call that get component method. And then in the angle brackets, we say what we need to grab, what type of thing we need to grab. I don't know, like a rigid body. That's something we'll often want to grab about our character. We'll grab the rigid body object, which goes in angle brackets, but it is not a coincidence that when we talk about a type of data in the C family, when we say, okay, we have this type of data, we use the same notation that we do for our markup languages. So what this is really saying is we have a player object. And in that object is a hit point object, which appears to be an integer from the way that data looks. Then a magic point object and a stamina object. Then we hit the end of the player data. So it really is object-oriented programming. It's a different appeal to it, but it's not a coincidence that it's the type the notation we use for a type of data in C family of languages. And then we have a bunch of these. Then we might have a player 2 object and all the stuff there. I'm gonna run out of room, so I'm just gonna write dot, dot, dot. We'd have a bunch of them. So it's actually an array of them, right? We fill up a text file. It's a specific size. We can't adapt that without changing the text file overall. So it's a set size once we have it. So along with that, it's also an array of objects. FXML is very similar. That's my favorite thing to make GUIs in Java with FXML, because but yes, anytime we're doing this with yeah, sorry, that something in the chat room popped up about FXML in Java. That works with a library called JavaFX. Interesting story there. So when Java was first created, they tried to create a GUIs package that was cross-platform and had all sorts of features, had nice features in it, and would work and look equally well on all our different platforms. And when they did that originally, they failed miserably. It failed every criteria you put that on. It did not look good on any platform, and it did not work good on any platform. So then they made a temporary one to hold as a placeholder while they figured it out. And that ended up being a problem that took them 22 years to figure out before they got something that looked good on every platform and worked good on every platform. So sometimes the problems are really, really big. That one took really good programmers decades to get figured out, the one in Java. But eventually they reached JavaFX. But along the way from those temporary platforms, they couldn't deprecate it because 20 years worth of programs had been written in Java Swing. And 20 years worth of programs of software, they couldn't deprecate the library after that. So to avoid that, they then made it its own thing. It's separate from Java, but it's still an independent thing. And then they extended it into markup languages, so it works with programming languages other than Java now as well. There's originally Java FX. I think now it's called OpenFX, so they don't get stuck. Oracle doesn't get stuck with something they can't deprecate, like what happened with Swing. And it's based on everything's been put into a markup language. We can still customize it, but it's a really nice package to make GUIs in. Sorry, I got a little distracted. Okay, so we have this object-oriented type stuff coming in as an array, and really it's an array filled with arrays. So that's where all that list stuff was coming from in this week's example, why they were using XML data there as opposed to JSON data. Or sequential text files or other forms. XML is kind of object-oriented data. It works well with games. And we have lots and lots of lists, which is sort of the structure of a card game, right? That, or if you just start thinking about a card game, that question we should ask every time we go to follow an example, right? Like the tutorials, you're reading through there. You don't want to just copy every line without ever thinking about what it is, right? I always suggest as you're reading through there, pause and look at the next step. So where's some examples here? So here's in the next game. So there might be one more before we get here. But in the chapter 35 game, reading through there, get to this step. Okay, enabling enemies to do damage. So every time you're reading through an example, you always want to pause there, right? It's like, okay, I need to set this up so the enemies can damage the player, and at least think quickly through how you would do the algorithm, and then follow along to see like what points you might have missed or how they do things differently, and make sure you understand it along the way as well. So that's where all the lists were coming from, because a card game, you should probably very quickly realize that's going to be a lot of lists. Or really arrays, because we know the size of everything in a card game. It didn't have to be list. We already know there's 52 cards in a deck. If we were making, like, say, a rummy game, we already know that every player gets 7 cards in their hand, or maybe a poker game. Rummy changes. In poker, every player gets 5 or 7 cards. If they want to swap those out with some other cards, they can trade them for other cards, but they won't end up with more than 5 or 7. So this format works really nicely with that. In a card game, it should be obvious that we really need that everything's going to be built off list, piled on top of list, piled on top of list, which is one of the examples this game was covering. The other thing that kind of gave me pause when I first saw it in the book was 29 pages of that were all about graphics, right? There's a whole lot of stuff to get those cards going. And what we're doing the next module, in module 6, we're going over sprite sheets. So doing our graphics that way gives us a big advantage when it comes to animations. When we're going to do animated things and work with pictures, instead of working with a whole bunch of complete pictures, we use the pieces of the picture are all separate things, and then we have code that puts them back together as needed, which I just thought of a great example from this. Sprite sheet. So that's what we're covering in the next module. So that then I decided, okay, that's going to be a good example of a good lead into it, because the cards are stationary. So all we have to do is kind of see about loading in data and how we can work with it. So next week when we get to animating it, this looks like it's probably the original sprite sheet. Yeah. We can work with all these different pictures or different pieces of it. That's not the one I was looking for. Those are all finished images. The original one has Mario in segments. The very original one, we have Mario's head, his torso, and then his legs are separate things. I guess you can kind of see it here. If you zoom in, you'll notice that there's a straight leg and a bent leg, a straight arm and a bent arm. And it's the original one just had those components, and then they were put back together in the code the same way we're building up our code. I don't see the picture here. I suddenly realized that would have been a great example to pull up. But it gives us a lot of advantages to working with that. Size isn't so much of a big deal, but we can do a size comparison real quick. Let's see. 20 years ago, size made a big deal. That's not really our one we worry about much anymore, but I guess it is still sort of a concern. So I go in the file cabinet, I'll go to the images I normally use for cards. I know I have them in an SDEV 120 class. I always use them. It's a good example of pictures for doing graphics with the Raptor in the SDEV 120 class. Probably this one. Oh, there it is. So if we go in here, I'll just grab one at random. View details. We can see it's 18 kilobytes. So not a very big picture. For the face cards more. These are the ones I usually use where we have a whole image and a whole bunch of images. 174 kilobytes. So the face cards are a little bit bigger. By far the vast majority of our cards, 3/4 of them are not face cards. So 3/4. So the average there is going to be around 40 kilobytes. So let's say 40 kilobyte size for a card. Whereas doing it this way, the sprites, well, the backs are much bigger, but the front of our card is 3 kilobytes, and it looks like 2 or 3 kilobytes for each one of the pips that go on the card. So we have much less data as far as image data, and then the scripts to put those together were pretty small. I think it was in card, wasn't it? We check the properties here. 1.8 kilobytes for that whole script. There's probably more in there than just putting the card together. So there's a size advantage that used to be really important. The other big one, if I pull up that Mario sprite sheet again. Any of these will work for this. This looks like it was ones people did later and not the original Nintendo one. The original Nintendo one had all the different things. So we had like Mario's head, Mario's body, a couple versions of legs, and a couple versions of arms. And then we would just use the one we needed for a particular frame of the animation put together in code. So a very small thing, but all of the images are in one file. And that's the idea of a sprite sheet. It made a big difference when everything was working off like spinning disk drives. Right? The biggest delay in retrieval time is to actually spin the disk around and move that read head into place. So if we only have to do that once, it can be a lot quicker than loading a whole bunch of separate images. Anymore, we load from an SSD drive where the opposite is true. It's actually more efficient to have lots of small images, kind of like the build thing for our Unity projects. Can I get this from the thing? Oh, there's a link in the chat room. There we go. Yeah, some of the original ones. Those still look like the full images. There was an original one but they got replaced with full images in the re-releases of the game. Like version 2, version 3, little the updates along the way. Things that improved enough they didn't need the original one. But yeah, there's the sprite sheet, all the different images that are used for that, and we control them as needed. It used to have a retrieval time thing, but like if I open the properties here, so our Unity project, 12,330 files. Some of those files might only have one line of code in. It's a bunch of instructions on how to build the project, but for modern solid state drives, instead of the spinning disk drives, it's better to have lots of small files. So instead of one big file with 12,000 lines, it's a lot more efficient to have 12,000 files with one line each. And the same goes to images. Like instead of having that, where's that one that was just put in the chat room? Versus this one? Is that the one I was looking at? So instead of having something like this, where they're all in one file, we have the same thing spread out amongst several files, but we still refer to either one as a sprite sheet. Knowing your system makes a difference. If you're working for a system that still uses spinning drives, I believe there are still some out there, right? There's still games that run off CDs, so we have to actually spin the CD to the right place and move the laser and the receiver, the optical sensor, the laser and the optical sensor that picks up the reflection into the right place. So there's a delay getting that to the right spot. So if we only have to move there once and then can grab all the data, it's more efficient than if we're on than if we have to move to a whole bunch of different spots around that CD or Blu-ray disc anymore. I don't think CDs are used for much of anything. I'm just in the habit of calling them the little round plastic disc where we burn spots that don't reflect or have a shiny surface, and then we burn some spots that don't reflect. So the reflection counts as a 1 and a non-reflection counts where we burnt it, counts as a 0. We have to move physical pieces into place. And if we only have to do that once and retrieve a big file, it's better for the spinning ones versus if we had to keep moving and finding different spots on the CD to grab the data from. So knowing the system you're on can make a difference on which one you're going there. And then all the graphics here, I thought that would make a good preview before we get into Sprite Sheets on Wednesday. And all that talking went for a lot longer than I intended it to. That was that. Okay, so that was everything I had on my list, but I was thinking that was going to be like 20 minutes of talking. We kind of just went double that, didn't we? But hopefully that all made sense, generalized it. Different thing, these concepts, we want to apply them in general, right? This class isn't called Unity. There's nothing about Unity in the name. It's game development in a general sense. So we want to make sure these concepts apply elsewhere. And our prototype game is a deck of cards, which, yeah, along with those image things, that's pretty common that we have to spend a lot of time working with those. Like it's over a quarter of this game, somewhere between a quarter and a third of the chapter is just dedicated to putting together those images. And that's fairly common even for placeholder images, right? When we just have the little things that we have there to work with while we're waiting on the art department to finish the nice stuff. And the stuff that the art department needs to finish needs to work with those codes. So there's a lot of interaction all the way through. We've seen that a few times. It's an art heavy thing. Our next module is about that. So sort of an introduction there. And then the other thing from that game is the surprising amount that goes into a card game. When people are new to programming, that's something that shows up over and over and over again, is just like a surprising amount of coding that goes into a card game, which is usually what people would think would be a nice, easy, simple example to start with. But that thought is typically based off like teaching kids to play games of cards, right? When we teach an intelligent species, an intelligent creature, that they can infer a lot of things and figure out little spots along the way, but machines can't. So all those little things that we take for granted on things like traditional human card games end up being a whole lot of code when we go to program those. But we're going to get into Sprite Sheets in detail in Module 6 and animations. We'll do one day on Sprite Sheets and one day on the 3D animations. Probably 3D animations first, because then once we put the Sprite Sheet together, we'll it follows suit of what we do with it to animate it so that we don't have to draw every single frame. We can code up those. And the code that the prototype pad is writing, there's a lot of software that already does that. We take the pieces and put it together, and then it fills in the gaps and does the animations and stuff. I usually do that stuff in Blender, and I take the little pieces, put them together in Blender, and then do the export from Blender into Unity. So to avoid writing all that code, but in a situation like this, the learning setting in a classroom, we need to take that stuff into consideration. Okay, so now on to our stuff. We'll take a look at that. Null reference. Oh, multiple versions of the same question. I guess we can take a look at it. So multiple versions of the same question, and it's probably coming on break time, so we can do our example after the break. So where are you all getting the null reference? Can one of y'all share your screen? I like tracking down bugs in the class because that's a little bit more useful than just kind of me sitting here rattling off what happens when things go correctly. Getting it from Prospector and Layout Game.
Yeah, it's the same thing I had sent you the other Sunday. Is the same error I've been dealing with the whole week.
Okay, well, you told me you had an error message, but you didn't send a picture of it or anything.
Oh, I thought I did. Of course I didn't. You want me to share my screen, or because
Yeah,
I mean mine can wait, but I've been stumped on this whole thing.
Yeah, because I like to go through the process in class.
Okay.
The process of tracking down errors is much more useful than the process of rattling off an example that I prepared for.
Because mine only happens when I load the game, and like as you can see, also my cards just aren't doing their thing either.
We're only seeing the back of the cards. Okay.
Yeah, they are changed. They're all different. But it says it's in line 78. I'm guessing in that area.
Okay. So
which is this line right here, and that's the only line I can't figure out why it's yelling at me about.
The thing we know is that the error happened somewhere before there. So that's a true or false value. Let's put true in there and see what's going on.
Where would you like me to put true? Or
instead of tsd.faceup.
Okay.
Temporary, yeah, the temporary thing .faceup, because faceup was just a Boolean. So manually type true in there.
I noticed too that there was a lot of errors. It's still, because when I click on it, it says it starts at 52 and then it's at this.
So to go back to our, yeah, so it crashed at 78. And if we go backwards from 78, so if
52's line is the, calling the.
Okay, so we might need a little bit more of that. So face up, see if changing that to false changes anything. Oh,
be helpful if I spelled it right, but
because true should have shown us the front of the cards. So somewhere it's missing one of the pictures. So let's trace back and see if we can find that. So that's what the null reference is. It doesn't have the front of the cards. It only has the back. Does that make sense?
Yeah. You want me to stop sharing and kind of go find that in the book?
Oh, yeah, I was just let's dig through here and kind of go through the process. So usually we look at the front of the card And then the way this game's set up, if we want to look at the back, it just draws the back in front of it.
Mm-hmm.
So we're only seeing the back,
Mm-hmm.
which means the front of the card isn't anywhere there to be drawn. So if we go back, there's a null reference on here, tsd.faceup. If we start going backwards, where my little pen go? That line has CP or TSD.
Mm-hmm.
So CP is the card prospector,
Mm-hmm.
which comes from draw. Where is the draw method?
Valid question.
And yeah, so when we write our code, we go beginning to end. But
Oh, now you say
whenever
that,
we hit a bug, we want to go to that line. And the only thing we know for certain is the error didn't happen after that line. So we just go to that line and work backwards.
Okay.
Your screen share stopped.
Yeah, I'll kind of dig for a second because I might have completely skipped the code somehow.
Oh, you don't see a draw method?
I do not see a draw method.
Share your screen. Let's do this.
Hold on.
You're in Sublime, right?
Yeah,
You have a find all for your project. So you can
I do.
do Control F and look through all of the open files for draw with a capital D.
That's the draw pile.
Since it didn't refer to another object, I'm guessing it should have been in that one.
I'm going to assume 2. That's why I did that. So because I'm going to take a stab and say I
Skipped it.
unable to-
Yeah, it's so easy to skip the examples in books. It's much easier to do our own thing because then we know what's going on the whole time. Let's check the book, see where it's supposed to go. Because the nice thing about ebooks is we have Control F here as well.
honestly, I've just this homework has been a beast.
Well, you were probably overwhelmed as well, right? You work. I know you work in a hotel by the river, and it was thunder over Louisville this weekend.
Yes.
So the hotel by the river was probably a little overwhelmed. Maybe put the parentheses in there.
Okay.
There's going to be a lot of draws. Okay, now there's only 4 of them.
There it is.
So it
And
returns a card prospector. Which class are we in here?
We are in. It looks like in prospector.
Okay, so
It should be right underneath layout game, which is
in object-oriented programming, our order does not matter for the methods. So you can put the methods, you can put it in anywhere.
no draws right there. There's the draw method.
There it is. So we've got back to this. So we draw the first thing from the pile, then remove that. There's another way to do that, and then we return that.
Oh no, it is CD. Okay. Thought maybe it was supposed to be CP because I've noticed there's that couple.
CP would have made. I renamed all kinds of things when I went through there.
Well, I noticed there was some
certainly
errors.
don't name things the same way this author did. All those things that started with like _T, like here on your screen, I see TCP, LCP, CP, TCD. I actually spelled those out. I usually wrote like temp card or temp definition, and I name things a little bit differently, but the reference names are irrelevant. So that should give us something. What's in the draw pile? So we're still going backwards. So that goes back. We're like manually doing a trace back because our trace back clearly went to the wrong spot, right? So let's go to where draw pile comes from.
I'm not sure where draw pile comes from.
I believe it's assigned on the interface. I think we set up the thing. Oh yeah, and then that name. I remember that one now. Yeah, I just called that method convert card. Which the method is down at the bottom. Yeah. Yeah, feel free to rename variables. I did it all the time working through the book stuff here, because I do not name stuff the same way he did, and those naming conventions were confusing me quite a bit. So I think the method for that's down at the bottom.
For draw pile.
Convert list card to list card prospector. So yeah, we have to just keep going backwards until we find. Or a quick way to find it is you go up there to the start method where it's at. Sublime does this. Double
There it
click.
is. That's right there.
Oh, okay.
It's right underneath it.
I was gonna say with it highlighted, hit Control F, and it will already be in your find box. That makes it a lot easier to find stuff, especially when code gets big. So that gives us, we look at this, get a new list, set up a card prospector for card and LCD. The rest of that looks good. So let's go back and find where LCD is. If you just highlight it and hit Control F, it should put it right in your find feature.
It's just those two spots.
Where's the other one?
Just right there.
Oh. Well, then that's a problem because that's a brand new list. So we passed that in. Okay, so where are we passing this in from is deck.cards. So one step further back. Oh, whoops. Right there.
Okay.
So we've just going backwards through the code till we find what's null.
So that would be
cards
in the deck, right?
And I believe we set that on the interface, don't we? Or is that here?
This has been
at the very least, if you hit run, we should be able to see the deck show up there. So down in the deck script, try highlighting the main camera and scroll down. Expand cards. There it is. So all our cards are there. So that can't be the null reference. Is there anything empty on this list? Let's look at this while we're here. Do you see anything not filled in?
No.
Or on the other list as well. So card name.
Is start face up supposed to be clicked?
Go ahead and click it. See what it does.
Nope.
Oh, well, I see where the null reference is though.
Where?
Look at the cards.
Yeah.
What? So there's something important. Something important missing there. We should have those pips on there. So where do we assign those?
Or do we assign the pips? I don't remember. Sadly.
Yes, we do assign them somewhere.
I remember
go back to
seeing it.
the book. And it's in the make card. Yeah, one of those. Add pips. We need the add pips method.
I swear I added that. That is in the make cards under the deck. Yeah, it's right there. That's what I'm saying. I'm completely confused to why I'm having so much problems.
Go down to where that method is. Yeah, we have to go back through and find what's not assigned. because that calls the method and then it assigns all of them, but it needs the image. So go back over to Unity and see if it knows what image to assign.
Where am I looking at that for?
Under decorators, should there be something there? I'm thinking we should have something. There was a spot to assign those somewhere on here. If you open the prefab card, the other one.
Like even, like I said, I know I messed up somewhere and I just don't know where I messed up at.
Oh, right there. I think that list right there under definition. If you expand that pips list, I think one of those is supposed to be our images. So let's look through. There's 29 instances of it. So if you scroll through pips here with the find thing, it would be up in this, somewhere up in the section where
right here's where they talk about adding the pips.
I think it's going to be up where we make the card. So a little bit earlier. Right around here. If you scroll down, like right after that code, this book seems to like write code, and then after the code, it says what you need to do in the Unity interface.
I just don't want to retype all this code to figure out where I messed up at. This was a lot of code.
Yeah, that seems to be the thing missing. Here, let me pull up mine and let's look at the assignments on the screen, which I guess I have to close this new one. Whoops. I think I just might have caused the Unity to crash. Oh, nope, not that one. Accidentally clicked both of them.
So you can go back to doing what you were doing, Chris. I mean,
we want to go. The process for finding this is actually probably a good one because there's so much to go through. So if we look at our prefab card, nope, not assigned there. Not assigned there. Somewhere there was a spot where those get assigned. Because we have all the pictures over
in your prefab card, you had something that said if you scroll down just a little bit more, you had state. Where did that come from?
From the enum.
I don't know why mine's not there. Wait, I'm confused now. I have the card script and you have the prospector script attached to it.
Oh, it does get replaced at some point. Because prospector is a subclass of card. That's apparently not where they get assigned. Because we have, oh, well, I have to do that on this on card, and it should not. There should be a prospector assigned. Mark asked in the chat room, is it supposed to say none for the card prospector then. No, I actually put, so we have all this stuff. There's a list of pips and card. And I guess we read those in. Then card prospector. Oh. Here's the enum. Here's where state comes from. That was probably one, the book had a big complicated name for the variable, but the card state enum. So in prospector, we have a state variable and then what's on top of it. And then that's all. Everything else was in the cards. So really all it does is tell us where the card is. Is it in the deck?
Oh, in the card, in the cards prospector.
Yeah.
I was looking at actual prospector.
Yeah, there's too many names. You want to share your screen again real quick? Let's look at it for up until break time in about 7 more minutes and see if we can track it down. But this is our process, so we're just going backwards.
Okay.
So at this point, we've got to where we can see the cards, but there's no pips on them. So that must be the null reference.
What do you mean? Okay, what is the pip supposed to do? I guess I'm confused on that part.
Oh, I'll draw one here. So, go ahead and run that real quick.
Okay.
Let me grab my little black pen.
Maybe that's why I'm really confused to what's going on.
So like on the 3 here, I don't know what 3 it is. So let's, a 5 of hearts. That's the pip. So we should have 5 of those images over here. I'll just draw circles.
Oh, I see what you're saying. Yeah, okay. And we're not, because the like 6 of diamonds that's underneath it doesn't even show the diamonds.
Yes.
And the 3 of clubs isn't showing, and so diamonds and clubs are currently missing from my screen.
Yes, and that's the null reference, and it's crashing on the way through there. We're getting hearts and spades, and then we put the small one in on hearts and spades, but we don't get any of the big ones in. So that, if you go to prospector. Okay, and Mark's having a similar error. So we'll kind of look at that here in a second. To where we make the cards. Was that in prospector? I think it was, wasn't it? Make card or add pips and all that stuff.
No, that was in the cards. Pips was in cards. Or
deck. So we read all the stuff from the XML file. Then we set our decoration.
Was I supposed to remove the XML files or leave them? Because it kind of just like skips over that part.
We want to leave them there.
Okay.
Because that has our data. If you open it up to look at it.
Okay.
If you go over to the project, you should be able to open it in Sublime here.
Okay.
Over to your assets and in resources is the XML file.
Right.
So here's our make cards. So down below that is add pips, I think.
Yes, right there.
Okay. So yeah, go to where the add pips thing gets called. Oh, down at the bottom of your code, I think. Oh, there we go. So for each decoration, so for each picture and
sorry,
definition,
I was gonna go find the code. We had
a temporary object, then we'll set the transform of that to wherever the card is. Then our local position is where we're at on the card. If it's flipped, we spin it around 180 degrees. If the scale's not 1, so the scale of not 1, that's the little ones for the corner. So on hearts and diamonds, it worked up to here, we know. Oh, that color's no good. We know it worked up to here because we saw those small ones in the corner.
Mm-hmm.
And then after that is where we didn't see anything anymore. So the name of our object is, it's going to be a pip. Then we get the sprite renderer component, set our sorting order, and add that. Is that what all they had here? So instantiate it, set the parent, the transform, if it's flipped, if we shrink it down, set the name, get the components. Oh, the TSR sprite, there's a line missing.
There is a line missing. See, I knew that it was something silly.
Oh, it's not silly. That's a lot of, it's much easier when we do it doing our own thing, because then we know what all the lines are supposed to do. Okay, there we go. So we looked through, that's where so the pictures, the sprites are loaded into that array. So we can just ask from that array.
So now when we go back, it theoretically shouldn't be screaming anymore.
Yes, hopefully.
No, it's still screaming.
I see some pictures. We have hearts and spades, but no clubs or diamonds. So I'm guessing those images, my first thought is those images might not be getting loaded into that array. So what was our array called?
Card dot suit.
Oh, so that's just a number. So our suits are like 1, 2, 3.
Dictionary suits.
Yes. So where's dictionary suits? Where do we load that in?
Up here.
Okay.
And then it's right here.
Suits club suit. Okay, so over on the Unity engine, is if you scroll up suit club and suit all that, those are things here. So does that have assignments? Has the club picture, diamond heart?
And just because, let's see, it was club, diamond, heart, spade.
Yes. And while you're over here on assets, go in the resource folder and open the XML. The deck. So here's that file we're reading. Here's that data. So we have our decorators, and then like the card 2 gets that particular pip. It gets XY positions up in the corners and where they're at on the main thing. So it's showing us all of it. So you can see it's just a bunch of coordinates. So putting files together like that can be easier than the graphics data when we make all the resources instead of just download them. So over in, back to where we were in the code.
It's 7:15, Chris.
Oh, okay. So probably a good time for a break. Yeah, so something in the code, I think, is looking for the wrong number, because it can find 2 and 3, right? That's our last 2. Hearts and spades are going to be 2 and 3, but it can't seem to find 0 and 1. But that's kind of how, that's the process. You go to where that error is, because sometimes those error messages, they only tell us where it crashed at. The computer can't tell us where the actual problem was, and you just go back through your code one line at a time until you find something missing. But now's probably a good time to take a break, and then we'll look at Mark's error and kind of go over the process and see differences and stuff. And then we should have the example. What I wanted to do for the example is going to go very quickly tonight. But does that make sense for tracking down the error, Tyler?
Uh-huh.
And
I might have just found the other error.
oh, did you?
Well, it
Oh, Mark said his error is the same as yours, just without the pips.
I'm wondering if make card is, did we ever like do the color black part here? Let me share my screen again. Because we have that part for diamonds and heart.
Oh, the default color was black.
Oh, okay.
When we created the card, we set it to black.
Oh, okay. So
Then
that
we only changed it to red for a couple for those two cases.
Oh, okay. So that part doesn't actually matter.
But that's what you want to do. Just go through each line, and make sure that's working. Let's take a break and then we'll look at it some more, because tracking down errors in code is an important is a more useful process than just watching me go through an example that was already prepared. So it's going to go smoothly and everything's going to go exactly like it was supposed to, because it's a bunch of selection structures kind of is the plan. But let's take 10 minutes. Does that sound good? Anybody? So 7:18. We'll get back to it at 7:28, and I'll see y'all in just a few minutes. I'm gonna go get some coffee. Oh, whoa, wrong button. I don't want to stop the meeting. Just want to stop the recording, not the meeting.